Hi, everybody, and welcome to this month's webinar. It's a topic that I think is really interesting. It's about gut health and this new term that you may have been hearing in human nutrition and other animals called the microbiome. So we're really going to start out with what we do know, and then how can that help us with what we're still learning about. We know that nutrition plays a huge role in obesity and immune function and inflammation and behavior, but to date we haven't really understood the connection between the two. So hopefully we might be able to delve into that a little bit further. Now, sorry if this gets a little bit sciencey, but I just want to show you some scientific papers that help build a story around what we have done with horses as we've domesticated them, and in particular, how we have changed the bugs that live in the horse's gut. So what do we know? We know that the horse is a grazing animal. He's meant to live in herds. He ferments most of that fiber in the hindgut. He's meant to take low energy, high fibrous forages and break them down. When they break that forage down, they break it down first into these things called short-chain fatty acids, and then they get further absorbed as energy sources for the horse. Excuse me. So you've all seen my digestion slides before. We've got the stomach, which is really small, the small intestine, which is about 70 feet in length, and in the small intestine we're going to be absorbing our non-structural carbohydrates like sugars and starches. There's enzymes that break down the food here, and then from here on back we have the hindgut of the horse, which starts with the cecum. Middle is the large colon and ends with the small colon. And this whole hindgut of the horse now relies on a myriad of different bacteria and microbes that ferment and break down fiber. We know that there's a certain critical amount of fiber for the horse. This fiber, at a bare minimum, needs to be at least 1% of the horse's diet. So if your horse is 1,000 pounds, he needs to eat at least 10 pounds of forage per day. You may have heard me talk about these minimums before, and I would much prefer to see your horse eat between 1.5 to 2.5% of their body weight. So we're looking at 15 to 25 pounds of fiber that they need to consume in a day. There's reasons why we need to do that. We know the numbers. We know the horse needs fiber, but why? We know the gut can help affect many functions in the horse, but how? So let's dig a little closer and look a little closer at what's really going on inside the horse. So if you've heard this term, the microbiome, I want to go a little deeper into what this is. A microbiome is a community of microorganisms living together in a particular habitat. Humans, animals, and plants have their own unique microbiomes. It's like a little community. The equine gut microbiome, in particular, refers to all of the microbes in the hindgut, which act as another organ that's critical for the horse's health. These microbes, they harvest nutrients and extract energy from the food and the forages that we feed our horses. They resist these bad bacteria, these pathogens that might get in the horse's gut. They develop the immune system, and they also detoxify the horse. What is this microbiome made up of? Bacteria, yeast or fungi, protozoa, viruses, and we think about viruses as being bad, but there are some good viruses, and this other smaller group called Acaria. Our microbes outnumber the cells in your body by a factor of 10 to 1. So we have millions of cells, but we have 10 million more microbes, right? We've got 10 more microbes for every cell in the body. So So many microbes that live in the gut and make up this microbiome. It can be affected by external factors. So we know that there are things that affect our horse from the outside, where it lives, the environment it lives in, when we change the feed, gastrointestinal diseases, dietary changes, what we feed our horses, acidic environments in the hindgut, laminitis, colitis, or colic. All of these things can actually affect the horse, and we know that, but now we have a little bit of an understanding how these things are actually affecting the horse. They're affecting the horse via the microbiome. So I said we'd look at a few papers, and I don't want you to be scared by these papers because we'll go through them. I just want to show you that there is a lot of science. Everything we do at DAC revolves around science, and there is a lot of science that has gone into understanding the microbiome and how it affects our animals and the things that we are outwardly seeing in our horses, and how the microbiome may be responsible for those things, those behavior changes, those sicknesses, the coat changes, the hoof quality, and why it's so very important to feed that microbiome. So what the supplements and the feed we feed the horses is absolutely critical. So this study in particular was looking at how the microbiome in the horse's gut has changed when we have domesticated horses. So on the left-hand side here, what we're looking at in these little plots is microbial diversity. The goal is we want to have a wide variety of different bacteria and microbes because they all do different things. But when we grow animals and foal animals out and they live in zoos, they have a really small microbial diversity, which is the same as if they're on our farms. They have small domesticated animals, have smaller microbial diversity. Now, these two populations, these are just names in the world where these wild reserves are. This Villeret is in France and Cyr is actually in Mongolia, and these are two groups of horses that are still considered wild, truly wild horses that they've been able to study via fecal samples, their microbial populations. And you can see they've got a much wider, just look at the box here. It's showing you this expanse of that microbial diversity. Oops. Now, okay, so that was looking at horses in zoos that had been domesticated, and then looking at two wild horse populations. So they're all over the world. Well, one might say, well, what if it's just the location of those animals that's causing that microbial diversity? This study took Mongolian horses that were domesticated, but they lived more like their wild ancestors, lived out on prairies. And then they took a group of thoroughbreds, housed them in Mongolia, so the environment is the same, but they put them in stalls, which is more typical of how thoroughbreds would live. So they looked at Mongolian horses versus thoroughbred horses, all housed in Mongolia on two different farms. Mongolian horses roamed and grazed the prairies, which is more typical of those wild ancestors, and the thoroughbreds were fed typical hay and grain rations and housed in stalls. Now, I know this is starting to get a little complicated, but don't get scared of these. The two main bacterial populations that you see in horses are called firmicutes and Bacteroides. So this blue section and this green section makes up the majority of this pie chart. And any of you that are on the phone, I will get you these slides, but know that firmicutes and Bacteroides are the two names of bacteria that make up the largest population in the horse's gut. But now between the horses living on the prairies and the thoroughbred horses living in the stalls, there's really no difference in the amount of those two bacteria. You're like, okay, well, she's going down the wrong path here. There's no difference between living on prairies or sticking the horses in stalls as far as their bacterial populations. But these are large groups. Then if we delve deeper, and look at how these break down, then we can see that there's differences within these groups. So, as I've mentioned, those firmicutes in previous horse studies have been shown to be the predominant bacteria. So we've shown what previous studies have also shown. Bacteroides, second to firmicutes, but also, same as in previous studies, these are very predominant in healthy horse populations. So Bacteroides and firmicutes are very high in healthy horse populations. One of the things that Bacteroides does is it's a bacteria that ferments carbohydrates and otherwise indigestible carbohydrates, and also produce these short-chain fatty acids, which is how the animal gets energy and nutrients. These short-chain fatty acids also help with gut healing. So the lining of the gut can be eroded by all the things that we do with it, and these Bacteroides help. They produce materials and nutrients and chemicals that actually help to heal the gut. So we need those two populations in healthy horses. Okay, so now here's the two main differences between the two breeds. 1% of the Mongolian horses and 4% of the thoroughbred horses had pathogenic bacteria. So we had significantly more of these thoroughbred horses had pathogenic, so salmonella, bad bacteria, were in these horses that ate higher grain diets and lived in stalls compared to the horses that were out grazing. Streptococcus, we know that that is also another bad bacteria, pathogenic bacteria, and that was 3% in the thoroughbred horses, but only 1% in the Mongolian horses. So, is this a link between wild horses being less susceptible to diseases versus horses that are stuck in stalls, or is it something to do with what we're feeding these horses? Are these thoroughbred horses more susceptible to disease? I'm not sure that we're able to answer a lot of these questions, but I think it's really important to show when we take horses away from a fibrous-based diet, when they're grazing in herds, and put them in a stall and feed them a grain-based ration, we do significantly change that gut bacteria, and not always for the positive. I'm not saying that we let all our horses live in the wild, but we need to understand what we're harming so that we can fix that with the supplements that we feed. So now let's look at fat horses versus thin horses. This was a study done here in Delaware, at the University of Delaware. And again, we're looking at those Bacteroides and firmicutes. And in the thin and normal horses, there's really not a lot of difference. But between the normal body weight horses and the fat horses, there's a significant difference. There's much less of the Bacteroides, and now the firmicutes have gone up. Now, this is similar to what we see in human obesity. Human obesity, they've shown a reduced amount of Bacteroides and an increased amount of those firmicutes in fecal samples. Okay? So, is there a relationship between these bacteria and obesity, or is the obesity what is causing? So obesity is a state of inflammation, and is that itself changing the bacterial population? Human obesity is associated with a reduction in insulin sensitivity. So people get diabetes, horses get insulin resistance, metabolic syndrome. And we also know that reduced insulin sensitivity has also been associated with a decrease in that microbial population. So fatness, obesity, metabolic syndrome, all those things decrease that microbial population. So now we're seeing, okay, I'm seeing several different groups of horses that should definitely need some kind of gut health supplement while they're trying to transition out of this disease. So fat horses, horses with metabolic syndrome, and horses living in stalls that have to eat a more grain hay-based diet all need to have some kind of gut health supplement to try and get that bacterial population to mimic those normal healthy horses. So let's go a little bit further. This group, again, the same group out of Delaware, looked at the microbiome, these bacteria, when we have easy and hard keepers. They actually ended up, during the study, finding out that we have hard keeping horses, we have easy keeping horses, but there's also this horse that seems to sit in the middle. He's not hard to keep weight on. He's not a super fat horse. He's just what they considered a medium keeper. He eats his grain. He maintains his body weight. He doesn't get thin and he doesn't get fat. He is just a middle of the road. So the hard keeping horses, those horses that are really hard to get weight on, they had the least bacterial diversity, right? Followed by the easy keepers. They also didn't have as much bacterial diversity as, you guessed it, the medium keeper horses, the healthiest horses had the most bacterial diversity. The horses that were really hard keepers didn't maintain their body weight well. They had less of these lactic acid producing bacteria. What do those lactic acid producing bacteria do? They break down carbohydrates. Carbohydrates helps with energy and body weight. They also had less amino acid utilizing bacteria. What are they? They are bacteria that help the animal break down and utilize protein in the diet. So a lot of these hard keepers, guess what they don't have? They don't have a top line. Maybe because they don't have the bacteria that are able to break down these amino acids to help them build that top line. So while we're over here throwing all the protein in the world at them, their bugs are saying, we can't break it down. How about you give us a gut health supplement so that we can normalize those bacteria so that they can do their job properly. The medium keepers are the most efficient at nutrient digestion and host absorption. Okay, so let's look at old horses and let's look at different diets that we feed them. High fiber, more like those normal natural diets. Now let's add some fat or some starch to the diet and see what that does to the microbial population. So we have adult horses that were about 5 to 12 years of age, and then their elderly population was between 19 and 28 years. So that's pretty representative of our senior horses. They had a hay diet, which was really low in carbohydrates, around 11%, and pretty low in fat, around 4%. Then they took that hay and they added carbohydrates to it, those non-structural carbohydrates. Now they boosted up the carbs to around 42%, but again, the fat still stayed the same, around 5%. Then the third group, they took the hay and they added fat. So now we've still got a pretty reasonable amount of non-structural carbohydrates, but we bumped that fat up to around 8.5%. And they looked at how the microbiome changed with these three different diets and in the two different age groups. So now we start to look a little deeper at this microbiome, and we'll hear this term called the core community. It's that central community. It's like the PTA. I'm learning all about that. My son just started kindergarten. I have not signed up for the PTA yet. But it's that core community that keeps the gut going, right? It's the base, that main powerhouse of the microbiome. And when we feed horses just hay alone, that core community, that strength in the middle, is about 15.9% of the overall microbiome. When you add oil to the diet, we start to back down that core community. And then carbohydrates, we really significantly decrease that core community. So when we're feeding really high carbohydrate diets to our racing horses, our barrel horses, those horses that need those high carbohydrate diets to go fast, it is even more imperative that anytime you feed a high carbohydrate diet that you must add a gut health supplement to complement that and help correct any of the damage that might be being done and balance it out, because we know we need the carbs for energy, but we also know that those carbs can do some damage, right? So also, one of these bacteria that live in this core community is called Lactospiraceae, and I don't expect you to remember the name of this bacteria, but just what it does. It produces butyrate, butyric acid or butyrate. Butyrate is known to have the protective function on the intestinal wall, the gut wall, right? It is what helps that gut wall stay nice and healthy. So the fecal microbiome really significantly changed between the three diets. It was also significantly reduced, or the microbial population was significantly reduced in those really senior horses. Now, is that just because these older horses, their bacteria is getting less and less because their gut health is breaking down? They're just less able to digest fiber? Is it something to do with dentition? Typically, these older horses have poor dentition. So, if cause or effect, I don't know. I just know that our really old senior horses need a lot of extra help. You've heard me before talk about leaky gut and how in the gut wall, these are the gut cells, and we have these little villi inside the intestines that increase the surface area. And between these little cells, there are these junctions or gate called tight junctions, and they are supposed to stay closed and not allow anything through other than digested food particles. But when the gut gets damaged, then we have this leaking of materials out of the intestines into the bloodstream. What do you think that butyrate is responsible for? That butyrate is responsible for keeping these tight junctions tight and keeping the gut healthy so we don't have leaking out. So now let's look at horses that came to a vet clinic that had colitis, so hindgut issues. Some call this hindgut ulcers, but really damage in that hindgut tissue. And this can lead to all kinds of terrible colic. It can be a result of colic. But this was a case study, and they looked at 16 horses, 6 healthy ones and 10 that had colitis, and they looked at fecal samples. Again, remember we said that firmicutes and Bacteroides are the two most common in the healthy horse? Again, in the healthy horses, over 60%, nearly 70% of the gut population in the healthy horses was firmicutes. In the horses with colitis, it was about 30%. So the firmicutes, these healthy bacteria, are significantly reduced in these horses that have colitis. When you break down, I said firmicutes was like an umbrella term, and underneath that, we break that down, we get down to those bacteria called Lactospiraceae, the ones we were talking about on the slide before, that produce what? Butyrate. Butyrate keeps the gut tissue healthy. Horses with colitis, their gut tissue is not healthy. It's breaking down and dying, and they have very few Lactospiraceae. Those Lactospiraceae have died off. So again, showing you that these microbiome, these bugs in the gut are absolutely critical. We need to understand where the population, how it sits in a healthy horse in its natural environment, and we need to try and do everything we can to replicate that in our horses. So now let's look at horses with metabolic syndrome. All now fed the same diet. So let's take out those horses were eating carbohydrates and maybe that caused it, or those horses had fat in the diet, maybe that caused it. Let's look at horses that are all getting the same diet, but some have equine metabolic syndrome and some do not. And this work's done out of the University of Kentucky. And again, we're just looking at microbial diversity. It's the simplest thing we can look at. In those healthy control horses, they had a really wide, look at how wide that rectangle is, a really wide microbial diversity. Look at the horses with equine metabolic syndrome. The microbial diversity was much, much less, right? And so it didn't have anything to do with diet at this point. This is completely due to a disease state. A disease state in these horses was affecting the gut. So diabetic horses or horses with equine metabolic syndrome, doesn't matter whether you put them on a low-carb diet, you still have to correct the gut. You still have to feed a gut health supplement. So now let's look at laminitis, because typically that's the thing that comes after equine metabolic syndrome. And again, in the healthy horses, they had a significant up to 70% of firmicutes, as we saw in the horses, that control group of the colitis study. And then the horses with laminitis had around 55%, significantly less of those firmicutes. Again, we need to work out. We need to correct the laminitis, but in order to do that, we have to go back to the gut. We also know that there's this thing called the gut-brain axis, and we hear a lot about that with feeding our children, how, red dye 30 can cause your kids to go crazy, and we shouldn't be feeding our kids a lot of synthetic sugars, high fructose corn syrup, blah, blah, blah. So the connection is, okay, if we have healthy gut function, healthy bacteria, normal gut microbiota, we have healthy levels of inflammation, and we have normal brain function. But now we go to a gut where the bacteria are all out of whack. It's causing inflammation in the body, and that goes up to the brain and alters brain function. Okay, you've all heard me say before, inflammation is the root of all evil, and in this case, that inflammation is being caused by bad bacteria, unbalanced bacteria, because of what you fed the animal. So this group actually looked at behavior. We know that we can feed different things to horses and change their behavior, but how does it actually work? So these folks looked at two different diets. They had a hay-only diet and then a hay-barley diet, where it was pretty much 50-50 hay-barley. So it was significant carbohydrates. And then they put the horses in a waiting pen and used a pretty standard kind of flight test that we do in research, where you open an umbrella and you see how long it takes them to go from point A to point B. And you also can measure different hormones to look at stress responses. And we certainly saw that the horses eating the high barley diet, they had more of those bacteria that break down high starches, and they had a behavioral response that you would be typical of anxiety. So we focus a lot of our time on the small intestine. You've heard me talk about that a lot when we talk about breaking down carbohydrates and grains, but it's all enzymatic digestion there. There's no bacteria that live there. We really need to focus more on the hindgut of the horse, the cecum, large colon, and the small colon. We need to focus on feeding strategies that promote a healthy microbiome and discourage those bad bacteria. The gut microbiome is the link between nutrition and health. You've also heard me say nutrition and health, they're linked, but now we know how they're linked. They're linked between this microbial population. We don't know the full extremities of this yet. We're learning it. It is the latest area of research that's going on in all animals and people. But here's a little bit of research from our recent equine science meeting. Now, yeast, Saccharomyces cerevisiae, this is something that we put in all of our gut health supplements. This is looking at yeast supplementation after you change the diet quickly. Now, we all know you shouldn't change the diet quickly, and we know that it can change those microbes in the gut. But if you add yeast to the diet, what does it do? So this group, it was in Europe where they have very lush grass. So going from hay to grass was a significant change. And so they had hay to grass and then grass back to hay, and they had those two yellow bars there are their transitions. And they gave the control group no yeast, and the treatment group, they gave them 20 grams of this live yeast, the Saccharomyces cerevisiae. And we know that we can change those gut bacteria. You can see diarrhea, gas when we make these sudden changes, colic, and it's to do with a sudden decrease in those Bacteroides, okay? We know those Bacteroides are really important. We need to keep those in healthy, normal horses. They're at high levels along with those firmicutes. But when they added the yeast to the diet, miraculously, they were able to maintain Bacteroides at the same level as if they were not changing the diet. So they did not see a change in those Bacteroides with the change in diet. It stayed really level. Now let's look at the old horses. We said earlier that the old horses, their gut's breaking down. They don't have great digestion, right? These now looked at prebiotics. So prebiotics aren't necessarily adding any nutrition to the horse, but they're helping to stabilize that bacteria. Prebiotics that we put in our feeds are moss, mannan oligosaccharide. This is just a different type of prebiotic. These horses, they had mature horses and senior horses. So mature horses they called around 7.5, but the senior horses were around 23 years of age. And when they were on the control diet, they just had hay and a ration balancer. And then the treatment group, they gave the prebiotic to on top of the hay and the ration balancer. So here is when we look at dry matter digestibility, hemicellulose, which is a non-digestible fiber, ADF and NDF are other measures of fiber. And you can see that there's a significant decrease. When you don't give the horses any prebiotic, there's a significant decrease in the senior horses in the digestion of all of these. The orange bars are less than the blue bars in all of these, showing that senior horses, that 20 plus age group, have much less digestive capacity for breaking down fiber. What is really important for maintaining that microbiome in its healthy populations is the ability to break down that fiber. Now, what they did find was when they added the prebiotic to the diet, there was no difference in those two groups, no difference in the two groups. So it was able to improve the digestive ability of those aged horses. So again, it's not just about adding yeast or a probiotic, it's also about adding a prebiotic. Now let's look at young horses, because we know that we can super stress these young horses. Now this actually started to look at, can we add yeast and help the stress with these young horses, and in particular exercise. Now, these folks actually looked at a joint tap. They looked at blood samples and they looked at actual joint fluid for levels of markers of stress. And at 8 weeks of being on this trial, they did an exercise test and tested again. So we can see here the control horses are these gray dashed bars, and then the darker bar is the horses that were being fed with the yeast supplement. And what we're looking at, for those of you on the phone, is we're looking at cortisol. Cortisol is a measure of stress. It is a stress hormone. So the goal here is that we want that stress hormone to be reduced quicker after our stressful event, our exercise event. So prior to the event, you can see that there's really no difference between the two. And then at hour 0, when we do that exercise test, again, no difference. But at hour 1 post-exercise and 6 hours post-exercise in these young horses, there is a significant reduction in stress in the horses that were given Saccharomyces. So the bacteria in the horse's gut may play a role in the stress response in horses. This is the same study, but now they measured this thing called serum amyloid. Well, now this just mirrors inflammation, okay? And for those of you, again, on the phone that aren't seeing these slides, again, at pre-exercise, both of the bars are exactly the same. At 0, time point 0, again, we've got no difference in this mirror of inflammation. At 1 hour post-exercise, we don't have any difference. But 6 hours post-exercise, we see that the serum amyloid, which is, again, that mirror of inflammation, is way, way up at the top of the chart, and it's only slightly increased with those horses that got yeast in the diet. So again, it helps decrease inflammation. It helps decrease stress and inflammation. And the only way that yeast can be having that function is via the microbiome. So, in summary, what do? We need to feed high quality forage, and we need to feed it consistently. But we also need to utilize feeding management practices that favor the microbiome. So that's feeding small meals often. It's making sure that that forage is provided all the time. But it's adding things to the diet that help feed that microbiome, help stabilize it even when we add stress to the diet that we can't take away. We're not going to stop trailering horses. We're not going to stop putting them in stalls. We're not going to stop feeding them grain. So how then do we mimic that microbiome? We use supplements that contain yeast, that contain moss, the probiotic. We use supplements that have ingredients that help heal that tissue. So what in the DAC range have we got? Day to day, we've got DDA. Therapeutically, we've got the Rescue Aid. We've got Cool Gut. In our vitamin mineral supplements, we add a small amount of the Saccharomyces cerevisiae, that yeast. So it's really, really important. I think I've pretty much shown every phase of the horse's life they should be getting a gut health supplement unless you've got a wild herd living in your backyard. So with that, I'll take any questions. I know it was a little sciencey, but I hope you stayed with me.